Welcome everyone. Before we begin, can you tell us, what is hydropower?
Of course. Hydropower is the use of flowing or falling water to generate electricity. It is one of the oldest and most reliable forms of renewable energy on the planet. Today in Lesson 1, we will walk through how it works and the different types that exist.
So what exactly is hydroelectric energy, and how is it different from other power sources?
Great question. Hydroelectricity is renewable energy that generates electricity purely from moving water. A dam holds water back, and when that water is released it flows through turbines, spinning them to produce electricity. Unlike coal or gas, no fuel is burned, so there is no pollution from fossil fuels. The bottom line is, we harness the natural motion of water and turn it directly into electrical power.
What is the core physics idea behind how hydropower actually works?
It all comes down to energy conversion, and it happens in 3 steps. First, water stored at a height has potential energy due to its position. Second, as it flows downward, that potential energy transforms into kinetic energy, the energy of motion. Third, turbines capture that kinetic energy and a generator converts it into electricity. So the full chain is, height becomes flow, flow spins turbines, and turbines make electricity.
Why is hydropower considered a renewable energy source?
Because it relies on the water cycle, which nature continuously replenishes. Rain falls on mountains and high ground, collects into rivers and reservoirs, flows through the dam to generate power, and then evaporates back into the atmosphere to fall as rain again. This cycle never runs out. And on top of that, hydropower is highly efficient, often converting more than 85% of the water's energy into electricity, with output that is reliable and controllable.
A hydroelectric dam looks very complex. What are all the key parts and what do they each do?
There are several important components. Water from the reservoir enters through the intake, passing a trash rack that filters out debris. Control gates regulate how much water flows through. The water then rushes down through a penstock, a large pipe, and spins turbines in the powerhouse, which drives a generator to produce electricity. A transformer steps up the voltage before it travels out on transmission lines. The spillway safely releases excess water during floods. And there is even a fish ladder, a step channel that allows fish to migrate upstream past the dam.
Where exactly does hydroelectric power come from? What locations or water sources are used?
Hydroelectric generation needs locations where water is either naturally moving or can be controlled. There are 3 main sources. First, waterfalls, like Niagara Falls, which have a natural, powerful drop. Second, flowing rivers, where the current is strong enough to drive turbines. And third, reservoirs created behind dams, where engineers control the release of water to generate electricity on demand.
Are there different types of hydroelectric systems? I thought it was just dams.
Actually, there are 5 distinct types. Number 1 is reservoir, or dam-based, hydropower, the classic large dam. Number 2 is run-of-river hydropower, which uses natural river flow with no large dam. Number 3 is pumped storage hydropower, which works like a giant rechargeable battery. Number 4 is tidal hydropower, which captures energy from ocean tides. And number 5 is micro and pico hydropower, small systems for homes and local communities. We will look at each one in detail now.
How does the classic reservoir dam-based hydropower system work?
In a reservoir system, a large dam is built across a river, creating a big lake of stored water behind it. The water is held at height, giving it lots of potential energy. When electricity is needed, control gates open and water rushes down through a penstock, a large pipe, spinning turbines in the powerhouse at the base of the dam. The turbines drive generators that produce electricity, which is then sent out via power lines. The big advantage is full control. Operators can increase or reduce output by adjusting the flow of water.
What is run-of-river hydropower and how is it different from a big dam?
Run-of-river hydropower uses the natural, continuous flow of a river rather than storing water behind a large dam. Only a small weir, a low barrier, is built to divert some water through turbines. Because the head height is lower, it depends more on the volume, or flow rate, of water passing through. The key advantages are significantly smaller environmental impact, because there is no large reservoir flooding land and habitats, and lower construction costs compared to building a full dam.
You mentioned pumped storage works like a battery. Can you explain how that works?
Certainly. Pumped storage has 2 reservoirs, one up high and one down low. When there is surplus electricity on the grid, for example, from solar or wind during the day, that cheap excess power is used to pump water uphill to the upper reservoir, storing it as potential energy. Then, when demand peaks, like in the evening, the water is released back down through turbines to generate electricity quickly. The key point is that this is mainly an energy storage technology, not a primary energy source. It acts as a giant battery to balance the electricity grid.
Can you show us what a real pumped storage facility actually looks like?
What you are seeing here is a real pumped storage reservoir, the lower basin in the foreground and the tall penstock tower carrying water up and down the hillside. These facilities are strategically located in hilly or mountainous areas where two reservoirs at different heights are practical to build. They are increasingly vital in modern energy systems as we integrate more solar and wind power, because they can store surplus energy and release it within minutes when the grid needs it.
How does tidal hydropower work, and what makes tides a useful energy source?
Tidal hydropower harnesses the rise and fall of ocean tides, which are driven by the gravitational pull of the Moon and the Sun on Earth's oceans. There are two main technologies. A tidal barrage is essentially a dam built across an estuary. As the tide flows in and out, water passes through turbines embedded in the barrage, generating electricity. Tidal stream turbines, on the other hand, are placed on the seabed in areas with strong tidal currents. They work just like underwater wind turbines. The major advantage of tidal energy is that it is extremely predictable. We know exactly when tides will rise and fall, making it one of the most reliable renewable sources.
These underwater turbines look amazing. How do they actually work on the seabed?
They work on exactly the same principle as wind turbines, but underwater. As tidal currents flow past, they push on the turbine blades and spin them. That rotation drives a generator inside the turbine housing, producing electricity which is sent to shore via undersea cables. They are anchored to the seabed on steel frames in locations where tidal currents are strongest. Because they are fully submerged, they have minimal visual impact and do not block shipping lanes, making them a low-disruption option for coastal communities.
Can ordinary people use hydropower for their own homes? Is it really possible at a small scale?
Absolutely, and that is exactly what micro and pico hydropower is designed for. Micro hydro systems can generate up to around 100 kilowatts, enough to power an entire small community. Pico hydro is even smaller, generating under 5 kilowatts, just enough for a single home or farm building. All you need is a small stream with a reasonable flow of water. These systems are ideal for remote homes that are not connected to the national grid, off-grid communities, and small sustainable agricultural projects. They are affordable, low maintenance, and produce clean power 24 hours a day.
What are the main advantages that make hydroelectric power so widely used around the world?
There are 5 key advantages. First, it is a renewable energy source. It uses natural water flow and burns no fuel. Second, it is clean energy. Hydroelectric plants produce zero carbon dioxide emissions during operation. Third, running costs are low. Once built, maintenance costs are relatively modest, around £50,000 per year for a 500 kilowatt plant. Fourth, it is reliable and flexible. Output can be increased almost instantly by releasing more water, making it excellent for meeting peak electricity demand. And fifth, it is safe, proven technology with a very long lifespan. Many hydro plants have been operating for over 100 years.
It sounds almost perfect, but surely hydroelectric power has some drawbacks too?
You are right. There are some significant limitations to consider. The first is high initial construction cost. Dams and power stations require enormous investment. The Niagara power plant, for example, cost around $800 million back in 1957. Second, there are environmental impacts. Building a dam floods large areas of land, destroying habitats and farmland, disrupting fish migration routes, and altering entire river ecosystems downstream. Third, suitable locations are limited. You need reliable rainfall, large rivers, and the right geography. The UK, for instance, has very few suitable sites. And fourth, output depends on weather and hydrology. During droughts, reduced rainfall means much lower power generation.
That was a really thorough lesson. What is the key takeaway from everything we have covered today?
The key takeaway is that hydropower is one of humanity's most versatile and proven energy technologies. From giant reservoir dams that power entire cities to tiny microhydro turbines. It is renewable, clean, reliable, and flexible. And while it does come with environmental and geographic challenges, it remains a cornerstone of the global shift towards sustainable energy. Thank you for joining us for this lesson on hydropower.